So it's really important to have kind of some number sense about these exponents. So if you have 10 squared, that means you have two copies, right? So it's 10 times 10, so that is going to be 100. If you have 10 cubed, that's going to be 10 times 10 times 10. And again, you can do this on your calculator if you want to. You can do 10 caret 3, okay, and that's going to give you 1,000. So what is important to remember is that if you have a positive exponent, all right, so a positive exponent like x to the second, x to the third, those positive exponents are generating numbers that are bigger than 1. Okay? So the number that you're going to get is going to be bigger than 1. Now, if you compare that to a negative exponent, all right? So a negative exponent such as 10 to the negative 1. That, remember what we do with our negative exponents, we move them down into the denominator, right? So this is really 1 over 10 to the first, and 1 divided by 10 is 0.1. So a negative exponent is actually generating for us a decimal, like a 0.1. And same thing here with this 10 to the negative 3, that's going to be 1 over 10 to the third. And if you calculate that 1 divided by 10 caret 3, that's going to give you a decimal. Okay, so it's going to give you a number between 0 and 1. So a negative exponent is going to end up with a number between 0 and 1. All right, and this is actually going to be the foundation of our scientific and standard notation formats for a number, is that anytime you have a positive exponent, it's a number that is bigger than 1. It's going to be a big number. And if you have a negative exponent, it's going to be a small number between 0 and 1. It's going to result in kind of a decimal format. So this is one of the top skills that you need for chemistry and other STEM classes, is converting between these two notations, standard and scientific notation. And the thing is scientific notation at the heart of it is based on this exponent property of a positive exponent gives you a number bigger than 1, and a negative exponent is going to give you a number between 0 and 1. So over here, we have our process for converting between the two notations. So remember, first of all, that standard notation is going to be the notation with all the zeros. All right, so standard is all the zeros, all zeros written. It's kind of a pain to deal with. How many zeros do I have type of thing. Okay, scientific notation. Okay, so for scientific notation, we are going to have a format of one single non-zero digit, then a decimal, and then all the trailing decimal point, and then all of the trailing numbers. Okay, and this little one, that is a non-zero number. Okay, so again, you're going to have a number that is not zero starting off your scientific notation, period, and then all the other numbers times 10 to a power. And that's our scientific notation. So when they give you a question in standard form and they ask you to convert it into scientific notation, a lot of times in like chemistry classes and so on, I know this was true when I took chemistry, is they kind of taught it where you had to like do a number line and all this stuff. And the problem was is half of the class would get confused as to which way on the number line we were going. So what I like to think about for converting between notations is the first thing that you're going to do is deal with that exponent, okay? And figure out, do I have a positive exponent here or a negative exponent? All right, so a negative exponent is going to be if your number is between 0 and 1. Positive exponent, I always think about positive exponent is going to be if you have a big number. So basically a big number greater than 1. So you can kind of think about between 0 and 1, you have like a small number between 0 and 1, it's a negative exponent. But if it's a big number greater than 1, then it's going to be a positive exponent. So here with this 730,000, you have a big number, right? So it's a big number. And so that means you'll have a positive exponent when you do your scientific notation. All right, so that's kind of the first step, is to figure out what type of exponent we're going to have. And I always write that down. I write down like, okay, it's a big number, it's going to be a positive exponent. Okay. Now, then I need to figure out where this decimal is going to go. So I need my first non-zero number is 7. And then my decimal point will go after that 7. So it'll be 7.3. Okay. Now, if it is just 0, like if it's just trailing zeros, you can drop those. If these numbers were non-zero, like if it was like 731,000 or something like that, you would need to write those non-zero numbers. But if it's just 0, you can drop them. So it's going to be 7.3. Okay, and again, that will follow under the structure of I have a non-zero number, my decimal point, and then the trailing terms. And again, any zeros that are trailing, we just drop them and have 0.3. And then times 10. Okay, now how many digits did we move? We started with our decimal point understood after this 0. If you count the digits, I have 1, 2, 3, 4, 5 digits between where the decimal started and stopped. So that means my exponent is going to be 10 to the 5th. Okay, so the power for scientific notation, that power or exponent is going to be the number of digits between the start and stop of the decimal. Okay. Now, another way you can do this is you can do the little loop-de-loop if that makes you feel better. You can definitely do that. So I always do the loop-de-loop. So my decimal starts here. So I go 1 digit, 2, 3, 4, 5. So that is 5 digits that I'm moving. So that means my power, my exponent, will be 5. Okay. And again, you can also just count them. You can go, okay, so it's 5 digits there. So that means my power is going to be 5. All right, so same thing for this one. First thing is to determine, okay, is it a big number, meaning that it's going to have a positive exponent, or is it a small number, meaning that it will have a negative exponent? So this is between 0 and 1. You can also think about it as it's a small number, and so that means you're going to have a negative exponent. And then from left to right, the first non-zero number is 1. So you're going to put 1.04 as the first part of your scientific notation, and then times 10 to its power. Now your decimal is going right here. So if you count those digits between where the decimal starts and stops, you have 1, 2, 3, 4, 5, 6. But then because it is between 0 and 1, you're using a negative exponent. So you'll have negative 6. So it'll be 1.04 times negative 6. Times 10 to the negative 6. All right, now I do need to mention something really quickly about the notation for this. You would kind of think that you can type in an X, and you cannot do that. Okay, so if you look here, I know this is really small, but like to the naked eye, it looks the same as what they're saying that the answer is versus what I said, but it's wrong. And that's because for the scientific notation questions, you have to use the little X that is on the toolbar. Okay, so that's a little bit of a frustration, but you must use the X that is on the tools template. So you cannot go on the keyboard and just type an X. You have to use the little X that's on the plus minus, the toolbar for that. Okay. All right. So what we're going to do, so what we'll do is we'll do the 1.04, go to the toolbar, click the X, and then type the 10 to the negative 6. All right. So going the other way, you would do the same process. You would think about, okay, what does this exponent tell me? So first, the exponent is negative. So that means that it's going to be a small number. So to get a small number, I'm going to have to move my decimal over to the left, right? So I'm going to start with 5.6. And to get a small number, I would need to move it left. And I need to move it left 7 digits. So I need to move it left 7 digits from where the decimal starts and stops. So it's going to be 5, and then I already have one digit with the 5, so I need to add 6 zeros so that where my decimal starts to where it stops, I will have 1, 2, 3, 4, 5, 6, 7 digits. Okay, now I know I have a little decimal in there, so it kind of makes it confusing what the answer is. So my standard notation would be 0.12345, 6, 5, 6. Okay, and that would be my answer. So again, this exponent is really going to drive your answer. So when you have that negative exponent, you know it's going to be a small number. So that means you're going to be moving it to the left in order to get a smaller number. You're not going to want to add zeros in the other direction. Move it to the left. And then because it's a -7, excuse me, we're going to move left 7 digits between where the decimal starts and stops. Now, comparing that to this 3.4 times 10 to the 8th, there we have a positive exponent. So that means we're going to have a big number. We want to make this number bigger, okay? And then we're going to move it 8 digits, okay? So I have 3.4. The 4 is going to be one of the digits. And then to make it bigger, I need to add 7 more digits to get a total of 8. So it's going to be 3, 4, 0, 0. I'm going to go 1, 2, 3, 4, 5, 6, 7. So where the decimal stops and where the decimal starts, I will have a total of 8 digits there. Okay. Then you can put the little commas in to make it clear what number you're working with there.